Welcome to Calculus AB video for skill number 122. I can extend my algebraic laws of limits to find infinite limits if they exist. And featured to the right is a column which is very plain in style. This is common to which order? There are three orders. Alright, we're going to talk about infinite limits today, and those are limits that approach infinity. So, for example, if we had the graph of 1 over x, which is the reciprocal function, we know that it goes like that. And if we approach 0 from the right-hand side, we are going to approach infinity. So the limit as x approaches 0 from the right-hand side of 1 over x is infinity. If we approach from the left-hand side, we find that we're going to be going forever downward, so the value there is negative infinity. There's a little typo there, we'll fix that. Because the left-hand and the right-hand limits both approach infinity, what we can do is consider this a vertical asymptote. So we have a vertical asymptote at x equals 0. And this is actually the technical way that we define vertical asymptotes with limits. So a vertical asymptote of a graph of the function y equals f of x occurs at a if either the limit as x approaches a from the positive side of f of x is plus or minus infinity, or the limit as x approaches a from the negative side of f of x is plus or minus infinity. Which means we can have a vertical asymptote where it only approaches on one side. So here's our vertical asymptote, like this, and then our function does that on the other side. So we don't have to have approaching the asymptote on both sides for it to be considered a vertical asymptote. Just one side. We're going to use this property with our vertical asymptote shifted to a value of a. So what we could do is apply this to our algebraic limit laws that we've been trying to work through with the last few skills. Let's see this in the next example. We're asked to find the limit as x approaches 3 of x minus 3 over x squared minus 6x plus 9. And if we do direct substitution, we're going to get 0 divided by 9 minus 18 plus 9, which is 0 over 0. So that's a divide by 0 error. And if we factor, we'll factor the numerator, which is already factored, and we can factor the denominator. And we see that it's a product of x minus 3 times x minus 3, and those cancel, and we're left with the limit as x approaches 3. And direct substitution doesn't work for us because we still get a divide by 0 error. So what we need to do is try a left-hand limit and a right-hand limit. So if we're approaching from the left, we're essentially calculating 1 divided by 2.9999, etc., minus 3, which is a very, very small negative number. So we're approaching negative infinity. And if we do it from the right-hand side, we'll find that we are getting a 1 divided by a very, very small positive number, so we're approaching positive infinity. Because our left limit and our right-hand limit do not agree with one another, the limit does not exist.
This is Batman. Hey Batman, I'm Spider-Man. Hi. Wanna watch a movie? Okay, but my boots are all sticky. Oh, that's okay. I believe this is your sandwich. Oh yeah, that's mine.
Alright, in example 2, what we have is the limit as x approaches 5 of x plus 5 over x squared minus 10x plus 25. And again, direct substitution, if we did that, we would have 10 over 0, and that's a divide by 0 error, so we're going to try a different approach. And what we do is first we try factoring, and when we factor we realize that nothing cancels. So if nothing cancels, then we're going to have to try another approach, and usually at this point with polynomials I'll switch to finding left hand and right hand limits. So starting with the left hand limit, I'm going to plug in a number just left of 5, so like 4.9999, and if I do that, what I wind up getting is some positive value on top, very close to not 10, so we'll say 9.9999. And then in the bottom I'm going to get a negative value, a very, very, very small negative value times another very, very small negative value. And so in essence what I'm getting is 1 over x. And if we take the limit of 1 over x, we approach infinity. Now we want to find the right hand limit, so we're going to plug a number just over 5 in there, which gives us a value of, we'll say 10.001 in the top, and then in the bottom we're going to get positive 0.0001 times positive 0.0001. And again, what we're doing is we're approaching something which very much resembles 1 over a very, very small number. So basically, we're going to get this approaching infinity again. Since the limits agree, the left-hand limit and the right-hand limit agree with one another, we can say that the limit as x goes to 5 of the function approaches positive infinity, which means graphically somewhere over here around 5 the curve is going to go up on both sides. The general rule that we can actually extract from all of this is that if the limit as x goes to 0 of 1 over x to the n equals infinity for all positive even values of n. If it is an odd value, then you're going to have a different left hand and right hand limit. So the limit does not exist at the exact value because one's positive and one's negative. Alright, thank you for watching the video for skill number 122. And as mentioned earlier, there are 3 orders, and the simplest or plainest of the 3 orders for columns is the Doric order. So the column to the left is considered Doric.